Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. I would like to present our paper entitled Optimizing Edible Film from Corn Cobs with Surface Response Method. We are a team of two, Ketut Sari and myself, Intan, as the second author, also presenting for this paper. We are from the Universitas Pembangunan Nasional Veteran Jawa Timur, Indonesia. The increasing production of plastic around the world is causing serious environmental problems because of the inability of plastic to decompose in nature. Edible film is an alternative packaging that can decompose naturally. Starch is one of the materials used to make an edible film, which is derived from corn cob. In this research, we investigated several compositions that determined the best combination of corn cob starch and plasticizers components, which are glycerol and sorbitol. The characteristic which determines the resulting edible films are the value of tensile, elongation, thickness, and water vapor permeability, and are in accordance with the Japanese Industrial Standards or JIS and also existing theories. The small surface method is a collection of mathematical and statistical methods used in modeling and analysis. It is capable of measuring the effect of several quantitative variables on a response variable and optimize it. The research methods are as follows. First is preparing the starch. Corn cobs were cut into small pieces and soaked for 12 hours. The deposit was obtained by washing the corn cobs, squeeze them with a filter cloth, and allowed to stand for 1 day. After the starch was dried in the oven, it was then grounded until smooth. Second is edible film making. We took starch of 5, 6, and 7 grams and also 5 different ratio of glycerol and sorbitol into a solution and at a heated temperature. The final edible film was printed, dried, and cooled to room temperature. These are the value of tensile strength, elongation, thickness, and permeability. All the 4 characteristics were measured and optimized using a Minitab. These are the counterplot of tensile strength versus ratio glycerol to sorbitol and starch weight for the first image. The best tensile strength have the darkest green color at a ratio of glycerol to sorbitol 2 to 8 and starch weight of 7 grams. This is due to the low ability of sorbitol to bind water and limit its ability to reduce hydrogen bonding of polymer chains. The second image on the lower left shows that the best elongation result has the darkest green color at a glycerol to sorbitol ratio of 8:2 and starch weight of 5 grams. This is because the increase in glycerol will reduce the cohesive bonds between polymers, thus forming a more elastic film. The third image at the top right shows the best thickness result has the dark green color at a ratio of glycerol to sorbitol 2 to 8 and starch weight of 7 grams. The increase in the concentration of the material in the suspension of the edible film causes the total amount of solid contained in it to increase, so that after the suspension is dried, the edible film obtained is thicker. And the fourth image at the bottom right shows that the best water solubility has the darkest color at the ratio of glycerol to sorbitol of 2 to 8 and starch weight of 5 grams. The high concentration of corn cob starch will increase the amount of film-forming polymer, thus reducing the voids in the gel formed on the film. The thicker and denser the film matrix makes the water vapor difficult to penetrate. And these are the surface plot of tensile strength versus ratio glycerol to sorbitol and starch for the first image. The best condition is shown at the top point at the graph, which shows the point of the glycerol to sorbitol ratio of 2 to 8 and a starch weight of 7 grams and produce a tensile strength of 0.5 MPa. The bottom left image shows the best condition, shows the top point of the graph, which the ratio of glycerol to sorbitol of 8 to 2 and a starch weight of 5 grams and produce an elongation of 21.4%. The top right image shows the best condition, and the ratio of glycerol to sorbitol is 2 to 8, and the starch weight is 7 grams, and produce a thickness of 0.26 millimeters. The fourth image on the bottom right shows the best condition of the ratio of glycerol to sorbitol is 2 to 8, and the starch weight of 5 grams, results in a permeability of 11.83 grams per meter square day. The output of optimization results were calculated with the surface response method using Minitab. The optimum condition at a glycerol sorbitol ratio is 1.42 or 5.875 to 4.125, with an amount of starch is 7 grams. These parameters produce the tensile strength of 0.4 MPa, elongation of 6.64%, water vapor permeability is 9.9 grams per meter square day, and the thickness is 0.21 millimeters. Most of these characteristics already met with the JIS standard, except the elongation value. Then, taken from conditions that are close to the optimum result, we had the glycerol to sorbitol ratio of 1, which is 5 to 5, and the amount of starch is 7 grams. The authors would like to acknowledge the financial support from the Ministry of Education, Culture, Research and Technology, the Republic of Indonesia, with an applied grant. Thank you very much. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.